What would you like me to cover today?
The exam?
What kind of things about the mind? That's it. Cool, no, that's specific. I can deal with that. Any other requests?
Corno. Yeah, the two-stage corno. So like when there's a sequential move, yeah, sequential move.
Okay, right. Yeah, let me write a list of
Question 12. 1 to 20.
Okay, any other requests? Nash equilibrium.
12 is 12 is the first one. Oh shit, that could easily fall on us.
What number are you?
No other requests people want to make?
More might come up.
Let's do some corner practice. Okay? So let's suppose you wanted
Sure.
if you come to the class last week. Okay, so let's do a corner example, okay?
Dude, that could easily fall over.
So let's do one we haven't done before.
Draw pictures.
Okay, so let's have a go at this problem. Yeah, I have no idea if it's going to have a nice round number answers because it's just some numbers I picked out of thin. Okay, so we've got a inverse demand curve. Okay, the price people are prepared to pay 10 minus 2 times total quantity, and we've got 3 firms with marginal cost 3, 2, 1. Okay, so this is a bit like one of the questions in the exam, but hopefully it's not exactly the same. So does someone want to have a go at this, or at least tell me what I should be doing? So what are we going to do first? Pardon? Profit. Okay, so what's the profit for the first firm? Well, profit is always, since this is marginal cost, okay, so we're no fixed costs, so profit is going to be quantity for firm sales times price minus marginal cost. That's one way of writing it. Okay. Quantity times price minus marginal cost. So this is quantity produced by firm 1, marginal cost of firm 1, and profits of firm 1. So we know what the price is as a function of total quantity. So that's the next thing we do. We substitute in. So this is Q1 times 10 minus 2Q minus C1, which is 3. Okay, so this is 7 minus 2Q. Q1 times 7 minus 2Q. Okay, so we've got an expression for profits. This is total quantity, remember, big Q. What are we going to do next? What do we want to do? Yeah, so we want to maximize profits, and the way you do that is by taking the first order condition. Okay, so first order condition says that the derivative of profits with respect to quantity should be equal to 0. And I'm going to do this in lots of steps, just so that it's completely clear what we're doing, okay? Because maybe I've rushed things too much in the past. So we're going to use the product rule here. For some of you this is boring, hopefully not too much. So remember, the derivative of u times v is u dash v plus v dash u. So this is our u, this is our v. Okay, so u dash, derivative of q1 with respect to q1, that's just 1. Okay, so we just get the v bit. Okay, so this is 7 minus 2q plus, that's separate. So the next thing we need is v dash, so the derivative of this with respect to q1. Well, derivative of constant is 0, so it's going to be minus 2 times the derivative of big Q with respect to q1. Okay, so this is, in brackets, minus 2 times derivative of big Q with respect to q1, all times this thing. Okay, so v dash u is our u, q1. So here we've got an expression, it's on 2 lines, sorry, with a d big Q, d little q. What's d big Q, d little q? 1, exactly. Okay, because big Q is q1 plus q2 plus q3. Okay, so this is just 7 minus 2q minus 2q1. Okay. So here's the first order condition for the first firm. Have I made a mistake? No, okay. Okay, so that's the first firm. The second firm is going to be very similar. Okay, it's just going to have marginal costs of 2 rather than 3. And remember, this 7 was 10 minus for marginal costs. Okay, so if you did the maths again, the first order condition for the second firm would be 8 minus 2q minus 2q1. And the first order condition for the third firm is going to be 9 minus 2q minus 2q1. Okay. Because, you know, you could do all this again, and remember this 10 came from 10 minus 3. And that gave us, we got 10 minus 3, that gave us the 7. Okay, so now for the other firms which have marginal costs of 2 and 1, we're going to get an 8 and a 9.
Could you get that? Well, yeah, wouldn't it be Q2 and Q3?
Yes. Yes. Q2, Q3.
Can we do that in the exam? Instead of like writing all the fully, can we just skip? Do that exactly, or not?
Yeah, I'd let. You know, if you wrote similarly.
Okay, yeah.
Similarly, yeah, I'd let you get away with that as long as you know it once, and then similarly, bang bang. Okay. So you've now got 3 first order conditions.
And do we need to put in a bit about dq dq1 being 1?
No, I just went through that just in case that was confusing people. No.
So you don't need to write all the rules of differentiation?
No, you don't need to write that. You know, you're supposed to know that by heart, but I'm just reminding you of it.
Yeah.
This is a random question.
Yeah.
Okay, so
This is like question.
so we've got 3 first order conditions. What's the next thing we do? Add them together. Someone say? Okay, so from adding them together, 7 plus 8 plus 9. 7 plus 8 is 15, so that's 24. Okay, is that right? 24 minus, minus 6q minus. And what do we get when we add these 3 bits together?
2q.
Big Q, exactly. 2 big Q. Okay, because big Q is just q1 plus q2 plus q3. So this is 24 minus 8q. Okay, so 8q is equal to 24, so q is equal to 3. Nice, it has a nice answer. So now how would we go and work out what quantities each firm was producing? So this is total quantity produced by all 3 firms together. How would we work out what quantity the first firm was producing?
Put it back into the
Yeah, exactly. So we put this back into the first order conditions. Okay. So here's the first order condition for the first firm. So that said 0 was equal to 7 minus 2q minus 2q1. Okay, and substituting in the value for total quantity, that's 7 minus 6, which is 1, so 1 minus 2q1. So q1 must be equal to a half. Okay, so the firm with the highest marginal cost isn't producing very much at all. That makes sense? You know, you expect the firm with the lowest marginal cost to be doing most of the production. So that's the first firm. The next firm, you know, we do the same thing again. So 0 is 8 minus 2 big Q minus 2q2. So this is 6, so 2 minus 2q2. So q2 is 1. And for the third firm, we've got 0 is 9 minus 2 big Q minus 2q3. 9 minus 6 is 3 minus 2q3. So q3 is 3 over 2. Does that add up to, yeah. So all we've done is taken these first order conditions, substituted in for big Q, okay, and that gives us an expression for its quantities. So it's very quick, you know, it doesn't take you very long at all to do this. So in the exam you've got 5 minutes, you can do that in 2 minutes easily. A lot of time.
You know what you're doing.
So is this clear? Are we happy with core node? Okay, so the next thing was entry. My list of things I have to do.
Oh, yeah.
Pardon?
He said giggity.
What?
Nothing, it's fine, it's a quite of something. It's fine, it's just a little joke.
I have it.
It's fine.
For the extra marks, what is it that you want us to explain properly?
Would that yield 10 marks?
Yeah, so for 10 marks I would, you know, I would have, I don't know. Maximize profits. I don't know, at a max.
Oh, I didn't know. At a maximum.
I don't know. Look, these things are relative, right? You know, the 8 is a lower bar. I'm not going to penalise you a lot for not writing things, but sometimes I get scripts where answers just mysteriously appear from the middle of nowhere, and then, you know, I'm not going to be too generous in that case. But as long as I can, you know, the more you write, the more convinced I am that you know what you're doing. You've just got to convince me that you know what you're doing, and that you're not just looking at the person next to you. So I don't like. I'm not a big fan of people writing marginal revenue plus marginal cost. So that would be one thing. You know, I'd rather you wrote down profits and differentiated rather than just using marginal revenue equals marginal cost, which, you know, that's a consequence of differentiating profits. That's what you get when you differentiate profits. It's better.
Could we set up like a general rule at the beginning and then refer to rule 1? Because the amount of times you have to write it, it's just, if you do it once and just refer to rule 1.
But you're not going to have to write, there's only a few monopoly problems.
It's a sentence.
Yeah, most of them are monopoly problems. Yeah, you get you know, you'd rather have fewer questions? So the point of having lots of questions is that so you can see, so we can cover all of the areas, you can get lots of feedback, and you can know how you're doing. You know, it's for your benefit, not for me. It's going to take me hours to mark this stuff. So I would rather just give you one hard question that I could mark in 5 minutes. You know, I'd be very happy with that. This is for your benefit, not for mine. It's only 10%, right? It doesn't. You know, it doesn't matter how long you do rounds. You know, so the worst you could possibly do, you know, I can't imagine any of you will get less than 50%, right? So the worst you could possibly do is you've lost 5 marks off your total score. It's nothing. And I don't, you know, I'm sure most of you are going to do very well. So, and did you actually want me to look at
Yeah.
that? Or was it
Like it's just the indifference between the fixed cost and total profit.
So maybe. Okay, so let's do a very simple corner problem with n firms to start with. Okay, so let's do I don't know, let's have a nice elastic command. Let's have P is 1 over Q. Okay, price is 1 over quantity. And let's have constant marginal cost of C. So profits of any firm is when, do you want me to talk about? Profits of any firm is the quantity that firm makes times the price minus its marginal cost. So substituting in for the price, this is QI times 1 over Q minus C. So this is profits from the second period. It's not overall profits including the fixed costs. It's just profits from the second period. Okay, so here's our profits. Next thing we're going to do is to differentiate profits to find the maximum. Okay, so same rule again. So this is going to be derivative of this is 1, so it's 1 over Q minus C plus QI times the derivative of this thing. It's the derivative of 1 over Q.
1 minus Q is about minus 2.
Yeah, minus 1 over Q squared. Okay, so what am I going to do next? Let's see if I... No, we'll work with that. So this is the first order condition for any firm. So in total for n firms, we're going to add all of the n first order conditions together, just like normal. Okay, so you're going to get n over q minus nc plus q, something like that, minus q times q divided by q squared. So this is 1q. So the sum of the QI's gave us a big Q, and then we've got the Q squared there, and then you've got n copies of this again. So then when we divide by n, okay, we get naught is 1 over Q minus C minus 1.
Then there'll be QI over the top. If you divide the last term by n, you get QI.
Divided everything but the
One
last
over
time by
n,
Oh yeah, of course. Okay, and now let's multiply both sides by q. Okay, so here, this was adding the first order conditions together. This is dividing by n. Okay, I missed put 1 over everywhere. Thank you for spelling that. So now let's multiply by q. Okay, so naught is 1 minus cq minus 1 over n. Okay, so q is 1 minus 1 over n all divided by sense? Okay, so here's our quantity. Let's just check it makes sense. If marginal costs are small, then the quantity produced is big. That makes sense. So note that if marginal costs go to 0, quantity produced goes to infinity, but that makes sense because of the shape of this demand curve. If n is big, then this is small, so this is big. So if n is big, then quantity is big. That makes sense. Okay, so it all seems to make sense. That's probably right. So here's our quantity. So the profits in the second period. This is the quantity, total quantity produced. What's the quantity produced by a single firm? Total quantity divided by the number of firms, right? Okay, so this is 1 over n minus 1 over n squared all over c. Okay, so the profits of a particular firm, just substituting in from the top. So we have QI times price minus cost. Okay, so QI is what we just worked out, 1 over n minus 1 over n squared over c. Price, remember, was 1 over big Q. Okay, and big Q we found as this expression. Okay, so this is c over 1 minus 1 over n. Minus, so there are some profits. We ought to be able to simplify this a bit. This is like, so we've got a divided by c on the bottom. We've got a c there and a c there. So the c's all cancel out. Okay, so this is 1 over n minus 1 over n squared all times 1 over 1 minus 1 over n minus 1. That's a bit simpler. Now let's make these fractions into a standard form, okay? And then we ought to be able to simplify a bit more. So this is n minus 1 over n squared, the first one. And this one, if you multiply top and bottom of this fraction by n, okay, you get n times n divided by n minus 1. So this is n divided by n minus 1. But then we've got the minus 1 bit. Minus 1 is like minus n minus 1. So n minus in brackets n minus 1. Okay, so the n's here are going to cancel out, and this is going to be plus 1. But we've got an n minus 1 there, and n minus 1 there. These two bits cancel out. Okay, so this is just 1 over n squared. So we got something nice in the end. Yeah, happy with that? Okay, so this is the profits from the production period. Okay, and the question I was asked was what the relationship was between the entry cost and the number of firms that entered and the profits from the production period. So here we've done the first part of the problem. We've worked out what the profits from the production period would be. So let's suppose that the cost of entering this industry was equal to 10. Okay, so suppose we have S equals 10. And we can work out what the profits would be, the total profits. So if you like the net profits, first cost of entry minus, production period profits minus cost of entry, when we vary the number of firms. Okay, so if n is 1, then the production period profits are going to be 1 over n squared, 1 over 1 squared, well that's 1. Okay, so here's n is 1, this is the table, n is 1, then pi I is 1, so the net profit, pi I minus f, my entry cost is too high, isn't it? I haven't thought this through. Let's have an entry cost of 1 over 10. That's a moment. Okay, entry cost is 1 over 10, not 10. Okay, so net profits in that case are 1 minus 1 over 10, so 9 over 10. Okay, so if only one firm entered, it would make a profit. What about if two firms entered? Well, in that case, pi I is 1 over 2 squared, so 1 over 4. Okay. So net profits are 1 over 4 minus f. So 1 over 4, so it's 1 over 4 minus 1 over 10, which is 3/20. Yeah, because 1 over 4 is 5 over 20, 1 over 10 is 2 over 20. Yeah. Okay, so if 3 firms entered, then pi I is 1 over 3 squared, so 1 over 9. Okay, we're still okay. 1 over 9 minus 1 over 10 is
1 over 90.
pardon?
1 over 90.
1 over 90, that makes sense. Okay, 4 firms entered, 1 over 16. 1 over 16 minus 1 over 10 equals minus something.
3 over 8.
3 over 8. Okay. So, suppose in this world that only one firm had entered. Okay, then if you like, there's a second firm sitting there who isn't entering, and at the moment he's playing the strategy of I'm not going to enter. What this says is that he has a profitable deviation. So this firm that currently isn't entering has a profitable deviation to entering, because if 2 firms enter, profits are positive. Okay? So if this was the outcome, then a third firm sitting there not entering would have a profitable deviation to entering, because with 3 firms entering, profits are still positive. But this is the Nash equilibrium for entry, 3 firms entering. Because if another firm came along and entered, that firm would end up making negative profits. So it would be worse off for entering. So it's not a profitable deviation. So the number of firms that enter is the biggest number of firms possible, such that profits are still positive.
For the negative profits, is that just firm number 4, or would that be all firms?
All firms would make negative profits if firm 4 entered. Obviously, firm 4 only cares about their own profits.
Likelihood is they'll probably make the least. But in realistic terms.
Well, that's kind of thinking about a dynamic situation. Yeah, we'll talk about things like that later in the class. So the proper way to solve these games is to do something like this: find the largest integer. But what we normally do in practice is we normally just approximate. Okay, so we normally say, well, at the optimum, the cost of entry must be approximately equal to the post-entry profits. Sorry, do you want to ask your question now? Or? Okay, so we normally just approach it this way. So at the optimum, firms must be making roughly 0 profits. Okay, if another firm enters, that firm that enters must make negative profits, and if one fewer firm had entered, all firms must be making large profits. Okay, so at the number of firms that enter, profits must be approximately 0. Okay, and if you look here, profits were 1 over 90, which is approximately 0. Okay, so this is the way we normally solve. We write the post-entry profits are approximately equal to the entry cost. Okay, so the entry cost was 1 over 10. and the post-entry profits were 1 over n squared. Okay, so if we invert both sides, this means that 10 must be approximately equal to n squared, so n must be approximately equal to the square root of 10, which is 3.7. Okay, this is going to be slightly bigger than 3. Obviously you realise that you can't have 3.1 firms entering until the answer is 3.
You said before that the national equilibrium would be the fourth.
3 firms entering.
The third.
3 firms entering. They all enter at the same time. So, although we tell this story about firms thinking about entering, really it's all happening simultaneously.
In the test on Friday, are the question structured in a way that we could do it the proper solution, or are we okay just to do the approximation and say this is not
have a
the
look at the
solution,
test.
however?
Yeah, so you can. So 13, I expect a whole number answer for question 13. It will be, it'll be 4 or 5. I'm not sure what the answer is, but have I just done that question from the
Well, no, different marginal. There was different marginal costs.
that
There were different marginal costs, so they're different.
That was the only entry.
Tom's face into something again.
So yes.
I think the numbers have changed now.
Something disgusting.
This is more of a sort of case situation.
Question 11, 10 is allowing.
Is that an okay trick? Because it makes it so much more easy to understand my own. What the one we did? That was question 11 I asked. 12 and 13. Because it doesn't give us a demand function. It just gives us a general function. So I make it inverse.
So I had a question about Nash equilibrium. Who was it? You guys at the back. So what was there a question in the mock that kind of brought this topic up, or were you just thinking generally?
Example 17. 17.
Yeah. Okay, so it's a question about these Bertrand things that you're struggling with, the whole number pricing Bertrand. Okay, so let's do another example of this. Okay, so let's suppose we've got 3 firms. First firm has marginal cost of 125. Second firm has marginal cost of 127. Third firm has marginal cost of 130. Those are numbers that I've used before. So the question was about how we find the Nash equilibrium. How we know we found the Nash equilibrium when we have one. Is that a fair assessment? So, what did the question ask? What did it ask for highest profits or something?
Yeah.
What's the net equilibrium height?
Oh, with
In
the
which
price
the
of
good is sold at the lowest.
The second lowest.
Okay, well, let's work a bit more generally rather than doing that particular question. So the way you go about finding Nash equilibrium is you start by guessing some numbers, and then you see if anyone would want to deviate. With these games, that's the easiest way. So, I might guess some really stupid numbers to start with. Okay, so let's suppose I guessed, I don't know, 180, 200, 50. Okay, there are some stupid numbers. Well, would anyone like to deviate here? Who's selling the good in this candidate equilibrium?
Firm 3.
Firm 3. Okay, so does firm 3 want to deviate?
No.
No, they have that full mark.
Oh yeah,
Yeah, they want to deviate out. Firm 3 would like to deviate to 179. What about firm 2? Does firm 2 want to deviate?
Down.
Yeah, firm 2 would like to deviate to 149. Firm 1 would also like to deviate to 149. Okay, so this was a stupid answer. Okay, so this is clearly not an equilibrium. But you can kind of, if you really wanted to, you could work in an iterative process like that. So suppose that we go to their deviations. 149, 149, 179. Have things got any better? Well, now this firm would now like to deviate down. So they'd like to go down to 148. This firm would like to deviate down by 1. This firm would like to deviate down by 1. So everyone would like to go to 148. I'm not suggesting this is the process you should use for finding equilibriums, just to help you understand what they are. So is this an equilibrium? They're all selling the same price now? Well, clearly not. Everyone would like to deviate down by another pound. Okay? So we could carry on repeating this process, and the prices would all move down together until we get to a point of, well, let's go to this point. 131, 131, 131. So now, firm 3 is currently making positive profits. Okay, but demand is being split 3 ways at this point. So firm 3 is making a little bit of profit. If firm 3 reduce their price to 130, they won't be making profit anymore. So this firm no longer wants to deviate. So we're closer to an equilibrium. Now one firm doesn't want to deviate. The other two do though. Okay, this guy would like to undercut to 130, as would this one. So let's have a look at 130, 131. Well, these two would still like to go lower. Let's go down to 128, 128, 131. This person is currently making positive profits of this candidate equilibrium. Okay, the demand is split between these two firms for both making £1. Yeah, so this firm is making £1 of profit per unit. So this firm wouldn't like to deviate down at this point. This firm would. So 127, 128. Let's have a look at that. That looks more promising. So is this an equilibrium?
Yeah.
Yeah. So this firm is currently the only firm selling. If they reduce their price, then they're just making less profit on each unit they sell. Okay, so they don't want to reduce their price. Do they want to increase their price? Well, if they increase their price to 128, say, then they're splitting the market with this firm. And they'd rather have the whole market with £7 profit, or half the market. Sorry, all the market with £2 profit. They prefer that to half the market with £3 profit. Unless the demand curve was going upwards or something crazy. But with sensible demand curves, they would this firm like to go down? Well, if this firm went down to 127, they'd be pricing their marginal cost, they'd be making no profit. They're currently making no profit, so they're indifferent. Okay? If they don't want to go down, if they want to go up, well, it doesn't make any difference to them either if they go up. And likewise with this one. So this is the general idea, okay? You're going to guess some numbers, and then you just see if any firm would like to deviate. And that's the definition of Nash equilibrium, basically. But at the Nash equilibrium, no player wants to deviate. So there's no change in behaviour that any one firm can make that would make them better off.
Is that the highest profits it can all make?
No, so for a potentially lots of Nash equilibria, and in one of the questions I think I was asking for the Nash equilibrium in which profits were highest, in which total profits were highest. So this is one Nash equilibria here. Here's another Nash equilibria, 126, 127. So this is also a Nash equilibria, because if this firm increases their price, then they're splitting the market. So they don't want to do that. Okay, the difference is, so these are both equilibria, these two rows. This one has higher profits than that one. So if I ask for the Nash equilibrium of highest profits, I'm just asking for one that looks like that rather than looking like that.
Do we have to state the one below, saying this is also equilibrium, or can we just say this is the one with the highest profits?
You can just say that's the one with highest profits. You know, so the rationale, if you wanted to justify your answer, I suppose the rationale is that if this firm was pricing above the marginal cost of the second firm, then the second firm would undercut. So this firm can't possibly be setting a price any higher than 127. So this is the highest price that that firm could be selling. Clearly, in equilibrium, that's the only firm that's going to be selling, so that must be the equilibrium of highest profits.
In the exams, you have to show what's not a Nash equilibrium.
No.
Can you just show what
Yeah.
it's?
Yeah, that's why I asked for a particular equilibrium, because there are lots of equilibria to these games generally. If I ask you to write all of them, you can very easily miss them. I've missed them quite often.
So would you count proof as just saying no firms would like to deviate?
So proof that it's a Nash equilibrium is just that, saying no firms would like to deviate.
So we need to do this in order to show that.
No. This was just to explain Nash equilibria to you a bit more. But to prove that it's a Nash equilibria, you just need to argue that no firms would like to deviate. And most of the time it's sufficiently obvious, but you don't need to write much at all. To prove that it's the equilibrium with highest profits, then maybe you need to write a little bit, okay, about why there can be one with even higher profits. Is that fair? Okay, anything else that you'd like me to cover? I'd rather discuss things now than tomorrow, because I'm not going to have super amounts of time tomorrow. Pardon? Welfare. Okay, well there were some questions that we lent from last week. Okay, so let's do a monopoly welfare question. Okay, so suppose for the industry facing this inverse demand curve, and just a monopolist in the industry. Okay, so the first thing we need to know is what price or quantity that monopolist is going to sell. Okay, and let's suppose that a monopolist has marginal costs of 2. So the profits of this monopolist are going to be quantity times price minus cost. Okay, so quantity times 24 minus 3q minus 2. Okay, this is a monopoly problem, so we don't have to worry about big Q in it. Show some really good numbers here. Okay, so at a maximum, the derivative of profits with respect to quantity should be equal to 0. Okay, so using the product rule again, derivative of this is 1. Minus 3.
When we solve for monopoly, do we have to use the product rule, or when it's like that, can we just multiply it out and differentiate it?
You can do what you like, yeah. You know, when it's like this, you don't need to do anything at all, because you know that the solution is halfway. So the root of this is 22 over 3, so Q must be equal to 22 over 6. And you know, it's what you have here as well. Q equals 22 over 6. Not a very nice number, sorry. So this is the quantity that's being produced. And the question I was asked was, how do we go about working out welfare? So, you know, the easiest way to do these welfare questions, I'm not going to ask you a welfare question, but involved in evaluating a nasty integral. You know, if I ask you a welfare question, it's probably one you can do by drawing a picture. So let's draw a picture. So here's our demand curve. This is 24 at that point. Okay, and we're interested. This is price and this is quantity, right? So the optimal Q is 22 over 6. So it's there. What's the price of this quantity?
13.
13. So to work out the price, you know, we just substitute into the demand curve. Okay, so 3 times 22 over 6 is 22 over 2. 24 minus 22, so 22 over 2 is 11. 24 minus 11 is 30. So that makes sense. Okay. So here's our triangle. What else do we need? We need this point as well. What's that point? How do we work out that point? Yeah, so it's the point at which the price is 0. Okay, so it must be 24 divided by 3. Sorry? 8. 24 divided by 3 is 8.
Yeah.
What? Someone says something else. Yeah, 8.
Yeah, we'll do that.
Okay, so we've got all of the points we need on this triangle now. So, you know, what are these different areas? What's this one? What's it called? Consumer surplus, this one. Yeah, this one. Yeah, okay, you know this. So, CS, PS, DWL. So what's consumer surplus here?
24 minus 13 times R times 20.
Yeah, exactly. So 24 minus 13 we said was 11, so it's 11 over 2 times 22 over 6. It's some messy number, okay? You know, it's not hard to work out these areas. So it doesn't have to be particularly difficult finding welfare. I guess you had something else in mind. Yeah. Yeah, that's all there is to finding out welfare.
Yeah.
So welfare is defined as consumer surplus plus producer surplus. So if I ask for welfare, I mean what's this plus this? Other questions?
Do you know when you said in some of the questions when you include infinite year zero, like mainly when you differentiate the profit function, it just like through a zero and all. So can you just say because Q is zero, therefore P is?
It's the division by zero, isn't it?
Yeah, some like one over
It's
here.
the division by zero. Does that count as division proof? If you divide something by zero, technically it's undefined. So in economics, you just take that as infinite.
Well, it depends. So what you're implicitly saying is you're making a limiting argument. You're saying, suppose Q got progressively closer to zero, it's still being positive, then 1 over Q would go to infinity. Okay, but if Q is negative, if you go -2, -1, -half, that goes to minus infinity, not plus infinity. So that's why you can't just write 1 over 0, therefore infinity, because it could be minus infinity as well. You have to know which side you're coming from.
Okay, yeah. But when it's squared, it'll be positive infinity anyway. If it's
but
1 over
with
Q
these,
squared, then it'll be positive infinity anyway. Yeah, that makes sense.
but those questions, you don't need to differentiate at all, really. When you write down the profit function, that kind of tells you everything you need to know, doesn't it? So if marginal cost is 0, price is 1 over Q, what's profits? So that's a bad example. What was I trying to get? Infinite price.
Yeah.
So that's the other question. What's my example? So suppose price was 1 over Q cubed. Then and marginal cost is 0, and profits are 1 over Q. Is that right? What?
Then prices can be infinite if your Q is really small and positive. And if it's really small and negative, then it'll be negative infinity. But if you're looking at if you look at 1 over Q to the 4, 1 over Q to the 2, then it's all on the same side, so it'll be positive anyway.
Yeah, no, it's fine. I confused myself for a second. So suppose price was 1 over Q cubed. Okay, I'm not going to do exactly the question from the last one. Basically, I won't ask you this question. So suppose there's a good chance I'll forget what we've covered here. So our marginal cost is 0. Then profits are price times quantity. Okay, so 1 over Q cubed times quantity. So 1 over Q squared. So you don't need to differentiate at this point. And if you start differentiating, I might even think you don't know what you're doing necessarily. Profits are monotonic, decreasing in quantity. Okay, as quantity increases, profits decrease, and that's true everywhere for positive quantity. So for any positive quantity, the firm could always increase its profits by reducing that quantity. So So if you like, yeah, you know, suppose Q was an equilibrium, then the firm would have a profitable deviation to Q over 2. That's one way to think about it. Okay, so at the optimum, Q goes to 0, price goes to infinity, profits go to infinity. I'm not sure there's much more to write.
Would that be sufficient proof in the exam if you were to get some of the questions, just going Q as a, and then just kind of follow on?
You know, I said a few things, right? I said a few things between there and there. So you write what I said. You write profits are decreasing in quantity. Therefore, the optimal quantity is 0.
Sorry, I'm backtracking a little bit, but you know in your previous example, like the welfare example,
Right.
why did you not go marginal cost?
I did. Oh, you. No, marginal cost was 2.
Yeah.
Yeah. Sorry. Well done. Yes. Thank you. Yeah. Well spotted. Thanks for pointing that out. So when you're doing welfare, you know, it's relying above the marginal cost to produce a surplus, so it's this area. Sorry. I forgot we had marginal cost somehow. If you like, the way to check it is to think what would happen under perfect competition. So perfect competition, price is equal to marginal cost. So you get all of this big triangle. So even under perfect competition, you don't get this area under marginal cost. Sorry about that. Okay, it's 5 o'clock. Unless anyone has any other questions, we can stop there. Everyone happy about Friday? Basically.
Happy is an exaggeration.
Give us all 100% we'll be happy about Friday.
I'm sure you